Okay, let me explain my code here. For this week, I created a new class sorting tree, which inherits from the binary tree. And here I didn't use any private attributes. I just call the constructor of the superclass of the binary tree to use its public method. And here I close the warning. The action is ignore, because later I will visit many nodes whose left child or right child is none, which will raise the warning. So I don't want to see too many warnings. And the first method is insert. With this method, I will have a tree. When I have a single value, I insert the value as a node of a binary tree, such that every node in the left subtree is less than or equal to the root, and every node in right subtree is greater than the root. So I first use the assert to handle exceptions for invalid values, like strings that like something that is not integer. And when I first insert nodes, I will find the current node. First, it will start as a root node. So I use this public method from the parent class get nodes. It will return the all the nodes in the tree. So the zero means the first element is the root node. And I then I use the recursion to implement the insert function. So I have two base case and two recursive case. The first base case is when the current node is when the value we input is less than the value of the current node, and the current node doesn't have the left child, like this. Imagine the current our value is one and the current node is two. When the current node is two and it doesn't have the left child, I insert the one as the left child of this two. And here I define a new name because for the previous superclass and just need a name for the node name. So here I use the n plus the string of the number of nodes in the tree. Because I started as zero, so it will be the number of the n plus the number of the existing nodes. And the base case for the and the other base case is almost the same. It eventually finds the parent node, and this current node doesn't have the right child. So the only difference is the condition. This is the left less than or equal to, and this is the right. This is greater than, and this is not have left child. This is not have the right child, and the other is this is a add node to the left. This add node to the right. This is also the method public method from the parent class. And let's see the two recursive case. For the first one, it is the number with our input value is less than the current node, but the current node has the left child. Like for the example, when we are at the root node, and our value is one. It is less than four, but the four has already had the left child. For this case, I use recursive to call the insert method itself, and the number is still the number, uh, the but here the second argument is not none. Instead, it is the current. It is the get node left of the current, which means If the current is 4, get node left of the current is 2, which means we will start at the left node of the current node instead of from the root node. So the other recursive case is almost the same. Um, it will check whether the number is greater than the value. If it is, and if the current node has already had the red child, it will um, visit its left child by inputting the get node red of the current node. So that is the insert method. And since we construct a binary tree whose array node in the left subtree is less than or equal to the root, and the array node in the right subtree is greater than the root. So when we consider a sorted list of the tree, we just use the in order traversal to implement this. Here I use an inner function, and for the left function I define a stack to store the element returned from the inner function. When the inner function is implemented, it will return many elements for each recursion, and I use this stack to store them. For the inner function, for the inner method, first I also determine whether the node is none. If it is none, then it means we also start at the root node. And here I have two recursive case and one base case. First, I determine whether the current node has the left child. Uh, for this example, if it doesn't have, for this two, it doesn't have left child, then I will execute the base case to add this element to the stack outside this inner function. Uh, if it has the left child for this recursive case, if it has the left child, for example, this 4, then I also call the method itself. I use the recursion. Then the inner parameter is not none, which means it won't start at the root node. Instead, it will start at its left child. If it is current node is 4, then the recursion will recursion means the when it calls the function, it will start at its left child, which is 2. And after determine its left child, after add the parent child, I will check whether it has the right child. For example, if this 2, it has no left child, and it has already added this 2 element to the stack outside, then I will check whether it has the right child. If it has the right child, I will call this recursion. I will call this method itself, and here the input value is the right child of the current node. It will be 3, and 3 doesn't have the left and the right, so it will append the 3. It will add 3 to the outer stack. So basically, the in order traversal is from the left and to the left child to the parent and to the right child, and after visited this 3, we can treat this 2 as the left child of this tree, and the left child is visited, then the parent, then the right. For the right, the 5 is the left child of this subtree, and the 5 is the left child, and the 6 is the parent, and the 7. And I think the in order traversal is acting like this. So when after I defining the inner method, I will execute the inner method with node, and then I will return the stack to return the sorted list. Okay, so now the requirement of the assignment is to use this list of numbers. I use the 6, the first element of this list, as the root node, and then uh, use loop iteration to insert the other elements. That is 6 is the root node, and use this for loop to insert the other elements. Okay, let's execute my code. Let's see the blocks. Okay, we can see that the left child is less than or equal to the parent, and the right child is greater than the parent. And the traverse, let's see, this is a sorted list 0 to 3, 3, 4, 6, 7, 12, 24, 63. It's increasing order. Okay, that is my assignments for this week.